Hi, we're going to continue our conversation about Pythagorean Theorem today, which we know is the relationship about sides of a right triangle, as well as area, which we discussed today in class as well. And I would like to take a look at some problems to see how it works. Okay, so first, this problem asks us to find the value of x. There should be a little right angle here. Assuming this is a right triangle, it's very important that we don't apply Pythagorean theorem if we don't know it's a right triangle. So let's assume this is a right triangle. Then to find the value of x, of course, I'm just saying that 4 squared plus 6 squared must equal x squared. And that gives us 16 plus 36 is equal to x squared, which means that x squared must equal 52. Not 52 squared, just 52. So to find the value of x, not x squared, remember I just want the length, not its area, I would take the square root of both sides. And I want to take a second to discuss simplifying radicals. Remember, we're trying to rewrite the square root of 52 as the product of two values. And if it simplifies, then one of these will be a perfect square. So if I think about factors of 52, we have like 2 and 26, or 4 and 13. And it turns out 4 is a perfect square. So if I rewrite the square root of 52 as square root of 4 times the square root of 13, we know the square root of 4 is 2, and our final answer would be that x is equal to 2 times the square root of 13. I would not say square root of 52, and I would not write a decimal. This is the exact value that is simplified, and this is something we really need to get good at. But let's take a look at one more problem. Okay, and this problem here is asking us to find the area, but we know the area of a triangle is 1/2 base times height, which means I'm going to have to find the height of this triangle here. I'll call it h. And one thing that hopefully we notice is that when I draw this perpendicular line, it creates two equal parts. So I'm really looking at this right triangle where this side is 4 and the hypotenuse length is 8, and I'm looking for this side over here. I'll call it, well, we called it h. Okay, so I know then that 4 squared plus h squared is going to equal 8 squared, and that gives me 16 plus 8 squared equals 64. And 8 squared is, if I subtract 16 from both sides, I get 8 squared is equal to 48, and h is equal to the square root of 48. Again, we'd like to reduce this if we can, and it turns out that the square root of 48, I'm looking for perfect squares again, so maybe you'd notice that it's equal to 4 and 12. But we can actually do better than that. We want to take the largest perfect square possible, so maybe 16 and 3, which means h is really equal to the square root of 16, which is 4, times the square root of 3. And that is our height. But to finish, we need to go back and find area. So area is going to be equal to 1/2 my original base, which is 8, times 4 root 3. So here 1/2 and 8 is 4, and 4 times 4 is 16. So my final answer is 16 square root of 3 centimeters squared. That is the area of this equilateral triangle. And we're going to do a lot more examples in class, but I'd like to they're going to be similar to this. I think you get the idea. I'd like to move on and talk about something closely related to all this. Okay, because the Pythagorean theorem is not just useful for finding lengths of sides, it's also useful for determining if something actually is a right triangle. So for instance, we talked about Pythagorean triples in class, but let's say I gave you a triangle and I told you that the lengths were, let's say it was, I don't know, 9, 12, and 15, and I asked you what type of triangle it is. Okay? Well, we can use Pythagorean theorem to help us, right? And I can test it. And it turns out in this case that 9 squared plus 12 squared would give me 81 plus 144, which is 225, and that is equal to 15 squared. So Pythagorean theorem works. We know this is a right triangle. We want to talk about what about situations where it doesn't work. And we have something called the triangle inequality that's going to help us with this. Okay, and the triangle inequality states that in order for a triangle to exist, if I took any two side lengths and added them together, that sum must be larger than the length of the third side. If you think about it this way, let's say I had a side length of 10 and I had two others that were like 5 and 3. Because of how long 10 is, there's no way I could ever connect a 5 and a 3 to get all the way to this other vertex, right? That's the idea. And I'm going to play with that in class to show you what I mean. But the idea is it could never quite reach. Even if I connected that 5, 1 to the 10, the 3 would not be long enough to get to this other vertex. I would never be able to close the figure. And so here you see some examples, right? 2 plus 5 is equal to 7, which is greater than 6. That works, right? 6 plus 8 is equal to 14, which is greater than 10. If I try these two smallest sides, again, 12 is bigger than 8. So all of these make triangles. Whereas if I looked over here on the right side, we see some examples here where that doesn't happen, right? 2 plus 5 is 7, and 7 is not greater than 8. So these two pieces, no matter how big I made this angle, if I had a 2 and a 5, the 8 would still be a little bit longer, right? The 7 of these added together would never get to the length of this 8, and that's the issue here. And same with all these, you can test them. So the question is, what if we know it makes a triangle, like these situations on the left, but I don't know what type? And Pythagorean Theorem is going to help us with that. Okay, so let's take a look at this example on the left. Say we are in a situation where we know 6, 8, 10 is a Pythagorean triple. We know that these sides form a right triangle. 6 squared plus 8 squared is indeed 10 squared. And if by comparison I look on the right side here, 6 squared plus 8 squared obviously doesn't equal 11 squared because it equals 10 squared. And if I look at this, the fact that my hypotenuse is longer, if I did 6 squared plus 8 squared, it's actually less than 11 squared, right? My hypotenuse squared is greater than the sum of my legs squared. So what does this mean about what would happen to this triangle over here? If I extended the length of this hypotenuse to 11, also, sorry, but note that 6 plus 8 is still greater than 11. So this is a triangle. We know it is some sort of triangle. We just don't know what type. But the idea is, since my hypotenuse, since my longest side is longer than 10, what's going to have to happen with my 6 and my 8 to reach this vertex, right? Imagine extending this guy over here a little bit longer. What would have to happen to this side? It's going to have to extend. Right? It's going to have to open up, and what it creates is an angle that is greater than 90 degrees. So we could say now that this is an obtuse triangle. Compare that to one more example. Let's say I had 6, 8, and 9. If I did 6 squared plus 8 squared, I would get 100. And 100 is greater than 9 squared, which is 81, right? I have, in this case, where my hypotenuse is shorter, I shouldn't say hypotenuse, because it's not a right triangle, right? But this longest leg is shorter than the other two added together, which means if I go back to this concept, let's say I had 6, 8, and 10 again. If I make this third leg shorter, then what's going to have to happen, I'm going to have to bring this 6 back in a little bit. And what it creates is now an acute angle down here. It's an angle less than 90 degrees. And this would happen all the time. We can use the Pythagorean theorem as a base for knowing that would create a right angle. If my hypotenuse is longer than the other two's added up, then it's going to be obtuse. If my hypotenuse is shorter, it's going to create an acute angle. So we can kind of generalize this, and I'll write down a quick little formula for you. Okay, and so given the fact that we have a triangle, in other words, the triangle inequality has to hold, so we know it does make some sort of triangle. If I know that's true, then I can look at a relationship of the sides squared to determine whether it's a right, acute, or obtuse triangle. Right? So if the Pythagorean theorem holds, obviously it's a right triangle. If the hypotenuse squared is smaller than the legs, then we have acute. And if the hypotenuse squared is greater than the legs squared, then we have an obtuse triangle. And we're going to look at some examples of this. Let me just give you a couple real quickly. Okay, so this first example here, all I need to do is say 4. Well, first I'll test the triangle inequality. 4 plus 6 is greater than 7, so it is a triangle. And 4 squared plus 6 squared equals 16 plus 36, which is 52, which is greater than 49, which means my hypotenuse is shorter and this is acute. And number 2, if I test my triangle inequality, 5 plus 11 is 16, meaning this is not a triangle at all. I don't even need to say what type it is. This doesn't even make a triangle. And this last example, if I do 4 squared plus 4 squared, I get 16 plus 16, which is 32. 32 is obviously greater than 4 squared, or 16. So again, my hypotenuse is too small, meaning this is an acute triangle. If I change this, say, to 7, then now I would still get 32 on the left side. On the right side, though, I would get 7 squared, which is 49, which would mean now this is an obtuse triangle. So it's a very quick check, and we're going to deal with this some more tomorrow. Hope that all made sense.